Finally, as the last part of the lecture on machine and assembly languages, let us look at some coding examples. As you remember, Hack implements only two kind of logics, the unconditional jump and the jump. So it is interesting to see how to implement other high-level logic functions, for example, if. Okay, here we show one possible implementation. You can come up with other codes easily. Let us start with the Hack convention. True will be represented by -1, false is represented by 0. So let's look at the high-level pseudocode of an if logic. Right? It starts with if a condition is fulfilled, then run code block 1, otherwise run code block 2. After the if code, the program continues with block 3. Let's see a possible implementation in Hack. Okay, so this will be our small code for the if logic. Let's see. You see that we write here a code that actually has the else branch first and then the true branch later. Okay, so we start accordingly. First, we fill D with the opposite of condition. Okay, it may actually take us several instructions in Hack. It also means that the value in the D register will be 0 if the condition is actually fulfilled, and -1 otherwise. Okay, then we prepare the jump for the true branch. We give the address of the instruction, first this instruction in the true branch, and then we make the program jump if there is 0 in the D register. Otherwise, that is, if the not condition was fulfilled, then the program continues with code block 2, that is the else branch. Finally, code block 2 completes, and then the program has to jump over the true branch. So we prepare a jump to code block 3, and the program jumps without any condition. Okay, similarly you can implement while, until, etc. logics. Finally, we look at the complete assembly program example. Okay, in C language, you can see what our program should do. It should add numbers from 1 to 100. Okay, in a high-level language, we typically have something like this. We initialize a variable, let's say I, to count what we add in a round. We initialize the sum of the addition, right, to 0. And then, for example, with the while loop, we add the numbers one by one to sum. Let's see how this code looks like in assembly, right, specifically in our Hack assembly. Right, the steps are similar. First, we need a couple of lines to initialize our variables. Note that our variables now actually refer to memory locations. Memory location with name I will store the numbers from 1 and then increasing them up to 100, and then memory location with name sum will store the actual sum of the addition. Okay, then we have a loop. We will leave this loop if the content of the memory location at I exceeds 100. Okay, so how do we start? First we take the value from memory location I, right? The value I is filled to the A register, so we have the address we have to look at, and then we take the value of this virtual register M and put it into D. So now the value at I is stored in register D. Then we have to compare this number to 100. So we put 100 into the A register, take the difference, and prepare a jump to the end of the program. Okay. And then we jump if D is larger than 0, that is, the value stored in I was larger than 100. Okay, if we do not jump, then again we take the value of I, right, because we destroyed D already. We store the value in the D register, look at the value at the address sum, and add to this value D. Okay, finally we have to increase the value stored at address I. Okay, that's what we do in these two instructions. Okay, and then we jump back to the beginning of the loop without any condition. Okay, so some remarks. Again, we note that our program has to end with an infinite loop. This is a constraint in our environment. Finally, let's again have a look at the variables and labels in our program. Right, they refer to locations at the instruction memory or at the data memory. Right, we have two variables, I and sum. They will be stored at memory locations 16 and 17. And we have two labels. They refer to locations in the instruction memory. To calculate this address, where this pointer loop actually points to, we have to count the number of instructions up to the point where, after a jump to loop, the program should continue from. So for loop it is, well, it is in this one is instruction 0, 1, 2, 3, 4. Okay, note again that this declaration loop is not a real instruction. It won't appear in the binary code. Okay, if you count down up to end, you will see that it has an address in the instruction memory of 18. Let us summarize this lecture. We covered the lecture material in 4 parts. In part 1, we introduced what a machine language and what an assembly language is, and we discussed the hack computer architecture at a level that is needed to understand how to design the machine language instructions. In part 2, we were talking about the machine language instructions, about the A and C instructions, and how these are related to the arithmetic unit implementation. In part 3, we were talking about symbol handling and input-output handling, discussed how the screen and the keyboard is represented in our computer. And in part 4, we covered some small coding examples. Okay, in the next lectures, first we will discuss, we will build the hack computer architecture, and in the lecture after that, we will address the assembler, that is the translator that translates assembly code to machine language. And as a project, you will write your first compiler in the course.